Hi everyone, welcome to a Wolfram Language Design Review for version 14.3. We are talking about LLMGraph. So, okay. So this is for the purpose of knitting together LLM calls, like LLM function type calls,
Exactly.
to support more complex workflows. Um, and to have asynchronous calls to LLMs, right?
Yep. I
Which
mean,
we, which we
to
already got that with
orchestrate
LLM
it.
synthesize submit, right?
Exactly. But that's a single call. Yeah,
Yeah.
like it has a asynchronous. It's an asynchronous call with tool execution and such. This is like a step up, and it's an orchestrator of LLM calls.
Yep. Okay. Okay.
So you want an example first or syntax first?
I want the example first, and I don't
Okay.
understand why this doesn't have. So this is that's a node in a graph,
Yeah.
and this is a shortening for LLM synthesize of generator haiku. Is that correct?
It's an LLM function. It's basically given that the node communicate with each other, the like full form is an LLM function. So which can, you can always wrap a prompt or a template in LLM function. So this is a
Yes.
function with no arguments. Yeah, this is the zero case.
Okay.
And then you apply. I mean, this graph is always applied asynchronously. Then we offer as a courtesy, but I think it's pretty important, the fact that you can actually run it like a net graph on input, and it will be
Okay.
blocking and return.
Here's the issue. Here's the issue. Okay. So graph evaluation, that directed acyclic evaluate and its friends.
Mm-hmm.
Where are we at with those? Because this should be consistent with that.
Not super close. And this is purposefully staying away from concepts like ports and such. You have only a bunch of nodes with prompts, and they can depend on each other.
Okay,
That's it.
but so effectively they have, it's like the LLM only has one input port.
It can have
Right?
more than one, but you cannot have like multiple output ports. Yeah, like basically for this design, the assumption is a node is its own output port. Yeah, no multiple things, no renamings. So we keep it simple, and you can already do almost everything with this. There's like you don't need like complicated the second argument to knit together the nodes. Like it's quite simple to use the template slots to do this. Or you can be explicit if you want and say, these nodes depend explicitly on this as input, and using an association syntax. So I see this as a very powerful update on LLM synthesize submit, and as a stepping stone to like more agentic workflows. That the more we look into this, the more would require like rethinking how we deal with asynchronous code in general. But that's a topic for another day, I would say.
Well, I don't understand that point. I mean, I think that, okay.
I mean, it's like, it's like the change of mindset between writing a neural network in a graph or writing it with code. So this is writing asynchronous code in a container. If you want like free form asynchronous code that doesn't use handlers and such, that's a deep overhauling or like rethinking of our asynchronous framework.
Yes, but I mean, that's also what we get with graph evaluation. We can imagine graph evaluation as being something where we have asynchronous
Yes, yeah, confined within the perimeter of the graph. Yeah, so like I'm preempting an objection here. Yeah, like it's true that you could do this with code, but there are a lot of things that needs to happen for
Oh
that
yeah,
to be.
you don't want to do it with code. You've got handlers and all kinds of weird stuff with code.
Yeah.
However, it is the case. Who's here doing project management? Is it just Avery?
Yeah.
Okay, so I need to move forward with it. I mean, the graph evaluation stuff somehow has been stuck. I haven't heard about it in the last couple of months. We need to figure out what's happening with that. That's
Okay.
And I don't know whether that was Nick or I mean, it was a thing that we were discussing primarily in ILD, but we had some specific things about graph evaluation. Roger was also involved, Charles, etc.
Charles, I mean, I was in the meeting with Charles like a couple of months ago, and we designed a graph with ports. So that part of the design will have to be presented to you, and it's quite solid, I think. The evaluation part needs to happen after that. After that, it's approved and everything.
The evaluation part can happen with ordinary graphs without ports. That's already, I mean, it's much more useful with ports. But I think it's also, that's a way into, asynchronous code organization, because that's what, the whole story of, causal graphs of code and things like this. This was the story of for example, just so we understand what kind of thing we're talking about here. Things like this effort of mine. This is about, evaluation graphs, basically. And that's what we need to be able to support. Right? I mean, this is the causal graph that you can get from our current evaluator, although our current evaluator sequentially, processes this with a sequential ordering.
Yeah. One node at a time. Yes.
Right, but it unravels this graph into something, linear, so to speak. But this is what, being able to represent this, and then, then the pieces can happen asynchronously. That's kind of where we're going. I know Nick has been working on this string diagram stuff, which is related to this also. But okay, we're avoiding that here. Here we're doing some sort of cheap asynchronousness. Okay, so here we're saying G2 of that topic. Okay, fine. But so where did this call G1? It didn't.
No, it didn't. It's another graph. This is I'm building up more complicated graphs as we go.
Well, what did you do with these? I mean,
I evaluated it. I mean, G1, like if you scroll up, G1 was write a haiku. Yeah. So that is, I say, LLM synthesized like. Yeah. So that is an LLM graph, which is effectively doing something which is the same as LLM synthesize with that prompt.
And so you evaluate with no LLM function. This one is just like an LLM function.
This is encapsulating an LLM function. Exactly. And then we can move up one step more and start with chaining. So this has like, hopefully you can read, should be self-explanatory.
Read it, yes.
Exactly. I hope it's self-documenting enough.
Yeah, it figures out, given this chain, I mean, the thing could have a loop in it, and it would figure that out. Is that true?
It will fail. It will, if you say, for example, in code, write a Wolfram language implementation of plan. Inside, you could write write a Wolfram language implementation of code, and it will fail.
Okay, so it requires an acyclic graph.
Exactly. Right now, we can imagine to expand it. We can imagine to expand it at some point, but yeah.
I don't think it needs an acyclic graph.
Then we need some sort of exit condition or something like exactly. So, but I mean, we don't want. We are pushing on the design a lot. This has been growing a lot in the past month or so. So at some point, we want to kind of stop and we have a decent run.
Number of features. So this is an LLM graph that you can apply to arguments.
Exactly. So in this case, the first node is plan, and it's still a node with no input. So I can just evaluate this graph with no input. And it
so what if there were two nodes with no input here?
Fine, it will just work. You can have plan 1 and plan 2 and pass it to two different nodes.
I see.
That's not a problem.
And where's the output? How does it define what the output is?
So by default, the output is the kind of terminal set of nodes. Yeah, the one that are not fed to input to anything else.
In what order does it come out if there are multiple terminal nodes?
In the order you write them. Timotei, actually, can you answer that? Is it correct?
Yeah, I mean, yes. And
how are they delimited?
It's an association.
It's an association with name goes to results.
So that's always what comes out from LLMGraph, even though that's not what I saw here. I just saw a haiku here.
Because in this case, there's only one terminal node. So the same case, you have a shortcut for the input and you have a shortcut for the output. You can say all, and you get always an association with all the nodes.
I see. Okay.
Yeah, let's say that is automatic. Yeah, that is what happens when you say second argument automatic.
Okay. Okay.
And the nice thing is that you can do second argument LLM graph.
Yeah, I like that.
And that returns, that's a new, it's not stateful, yeah, it's stateless, but that's a new LLM graph with all the results like contained within it.
I see. So in other words, it's an instantiated graph.
Exactly. And what I like is that it's exactly the same structure. It just has more data in. Yeah, and if you use the submit version, you can get incrementally more filled in graphs.
Yeah, that's nice.
So you don't have to learn anything new. Yeah, it's always the same.
And so there's an LLM graph submit, is that correct?
Exactly. That takes the graph and the inputs and then gives you like stuff.
But how does it give back? Well, we'll look at that in a minute.
Yeah.
The heck is this?
The result. I mean, here so the part you want to check is that I'm getting information of nodes. So this is basically getting out the nodes, and I'm looking up the result that has been attached to each node. Yeah, and then I'm just putting those in a panel. So you see here the plan, the code, and the test.
I see.
Okay. So this is the first example of more complex workflow. Yeah, that this in this case is done automatically. Then you can have like more things. Yeah, for example, here is a tree of thoughts instead of a chain of thought. So in this case, I use an LLM function because I want to specify two different evaluators. One is using Anthropic, one is using OpenAI. Yeah, and then I have a judge that will pick the best. So then we didn't spend too much time to trying the different problems. So in this specific problem that you have here, they managed to solve it the same, and the judge says like they're equivalent, fine. But you can imagine,
so in this case, I could have said G tree of null association, graph, and I would have got the same result. Is that correct?
No, you can say G3 of null association LLM graph, and that you get something which is G3. Yeah, because you are.
No, I understand. To get this graph out, I don't understand why I can't say G tree of null association, graph based on the syntax you had before. Why isn't that going to give me the right thing?
We could support that. We are using information for property extraction, but that is not going to conflict with the point is
LLM graph. Right now, LLM graph has the feature that its sub-value is an evaluation.
Exactly.
Just like it is for LLM function.
Exactly. And I don't think we're going to mix that with property extraction.
No, we don't. That was a mistake we made previously. But I'm wondering.
Exactly.
I guess the correct name is LLM graph. It's a little bit weird that a graph doesn't take sub-values. But this is a graph-like thing that is taking sub-values.
I mean, NetGraph does the same. Yeah, it evaluates exactly the same.
Fair enough. Okay, all right, okay. But so now for NetGraph, what is the analogous thing here? There's a graph for NetGraph.
Yeah, information, and you get summary graphics or like summary graph.
Okay, give me an example of a NetGraph.
I don't know. You could say one goes to.
What's that?
Yeah.
Net.
No, it's not a graph. It's not a graph, but yeah.
It's just change.
No, do image identify net, and then net flatten.
Oh, there's a V2.
Yeah, we updated that a couple of years ago.
Okay, and now
you net flatten, and that becomes a graph because inside is a graph. It's large, so it takes a bit. Okay, now you have a full graph. So now this thing can be applied. Oh yeah, we can do information. Yes. Summary. I think it's called summary graphics.
Yeah.
Summary graph.
Well, why can't I just have
I could
graph?
check. We could add we could totally add the I'm realizing now we could totally add the synonym. You should have a list of properties. Let me find how it's called. Is okay, summary graphic, and then is actually how is called? How is called? Topological
Layers graph?
Yes, layers graph. There it is. Spot.
By the way, could you mark this timestamp, Avery, and show that to user assistants as a typing case that is just horribly wrong?
Yeah, oh yes, please.
Okay, so after a name like that, typing a single quote should not double the quote. Right? I think maybe I can just do it here. Yeah, that's just wrong. That shouldn't happen that way. Right? You could just send that in to user assistants.
Yeah, I can do that.
Probably even without the video, because it's so easy to reproduce. Okay, that's cool. Okay. Okay, fine. I mean, let's make these things compatible.
Mm-hmm.
Okay.
I mean, it's a bit boring example, but
yeah,
because they do the same. But you know, you can imagine the applications here. And of course, if you get the second argument LLMGraph or all, you can see all the, you know, by chance in this case it. Oh no, sorry, it wasn't this one. Like in this case, it's not actually showing the problem.
You know, the color coding here be the same as for proof graphs and so on. You know, let's make sure we have some consistency there.
Yeah, this is work in progress. I need to talk to design and make sure that I get the right inspiration.
Remind them, proof graph and net graph are two, you know, samples of what we're trying to be compatible with.
Proof object. Okay, I'm going to look into that. Yeah.
Okay.
Okay, now we go into like the naming game. So these next two, listability and conditionals, are stuff that will make it super powerful. We need a bit to decide how to package this. I mean, this is not terrible, but
okay, let's take a look here.
Yeah.
Okay. What does this even mean? So these are user names, chunk and chunk summary and final summary.
Yeah, exactly. Yeah.
Okay. But this template and listable are not user names. Those are built-in names.
Exactly. So right now we have function like template, which is the one that you have if you don't put the association. If you use the association, you get access to function and inputs that lets you, you know, apply arbitrary code in this. And in this case, listable. Listable means, you know, if you get a list of inputs, don't pass the list to the LLM function, but map LLM function over the list.
I understand.
So basically, this is a quick and dirty implementation of text summarize that works in parallel. Of course, we are also going to update text summarize to work in parallel. But this is if you want to write it today.
What is inputs? What quotes text?
Text is like writing the template. You know, please summarize the following text. But
wait a minute. Is text a user supplied thing, or is that a built-in?
It is the user supplied thing.
Alice in Wonderland in this case.
But why did we name it text?
No, it was because we decided so. Could be full.
But how are you using?
Inside the function, you see string partition text up to that has to match. Yeah, that has to match.
I see.
I mean, the point is for templates, we are figuring it out automatically using template slot.
Okay,
for
so
functions,
but inputs, what you're doing is you're saying if it's got n inputs, you're going to. So, for example, I could say something like, LLM graph of inputs of A, B, C, and that will then mean that if I feed LLM graph X, Y, Z like this, or no, maybe in a list.
No, it's an association. It's always an association. We are, I mean, right now we are conservative. The shortcut is only working if you have a single input.
Why am I specifying the inputs if I've got? I mean, if the thing
because a single input is a shortcut for an association with only one key. The moment you generalize to multiple,
what's the key?
Text. The key? In this case, would be
no. Why is it text? Why is it, if it's a single input, is there a default key?
No. So in this case, we say inputs goes to text. So you have two options here. Either you provide an association with one key, which is called text. I mean, you can provide more, but they will be ignored. Yeah. Or you provide something that we know how to expand to the association. So we do the courtesy.
Okay, so in this case, if I removed this, I could feed this whole LLM graph a thing that says, text, arrow, whatever, and it would work. Is that correct?
No, it's the opposite. It works this way because you have input text. And this is because it's easy to look for template slot in a template object, but we typically don't want to do code inspection to find slot in functions.
Okay, so I don't understand what this is doing. In this case here, okay, if I have a function, what am I feeding into? Can I refer to hash A in my function?
Exactly.
But then what do I feed as input here?
Hash A.
No. I mean
no. So hash A. No, sorry, key A, not hash A. Key A. This requires key A, key B, and key C, and then you can reuse them in function. This is bindings basically.
But why do I need to say inputs there? You know what's coming in, except in this case here, where I've elided the name of the key. In this case here, I know what the keys are because they're right there in the input.
When we build the LLM graph, we don't inspect the function. So node can have either a template or a pure function. We don't inspect the pure function. We expect user to declare.
I understand that. I understand.
Okay.
So you're saying you build the LLM graph not at runtime, therefore you don't yet know what the actual inputs are going to be.
Exactly. Because I mean, if you just look at the summarized graph that you had there, if you remove inputs, the only alternative I have is to look inside function.
No, I got it.
And that's like
okay, I got it. Okay. Question for linear layer or something. It has a way of specifying inputs. How does that relate to this?
No, it doesn't. It has a fixed ports. Linear layer has an input port called input.
Okay, so what about net graph?
Net graphs will have a second argument that defines the connectivity, and then you explicitly say net port foo goes to 1, for example. And the reason why we don't want to go there is because that is the part that requires the graph evaluation and graph reports to be done. We are not using a second argument here, which would naturally be the connectivity, because we don't want to introduce an LLM graph port. Yeah, we would like to be consistent with that syntax.
Okay, but the inputs thing here is not something that appears in net graphs. Is that correct?
Well, we do have input ports in layers that are like bararg, like catenate layer. And that is like input ports like 1, 2, or 3 with automatic name, or you could say input ports foo bar buzz, and that would take an association.
But is the name input ports, or how do we specify those inputs? Is it a thing like the inputs that we're using here or not?
It's similar in a sense, because the layer takes an association then with those names. Let me go back to input ports and check. I think it's exactly that. The only reason I'm willing to be using like input ports as an option is because we managed to never mention ports in this design for like compatibility reason. But yes, you could say input port goes to name 1, name 2, and this is basically ports without shape.
Okay, listability. Okay.
Okay.
So we've got all these wrappers about threading and so on that we're using for tabular. Can we not use one of those wrappers for the template? And maybe generalized string template to have such a wrapper as well.
We have a nice wrapper which is threaded, but it applies to the argument, not to the function.
Right, but
there's column-wise thread or column-wise value, but that's very targeted towards putting stuff in a column.
Okay. So I would think it was better, okay,
yeah,
to call it template and then something like listable template. See what I'm saying? You can choose. It's either a template or a listable template.
Okay. So this would also solve Timothee's problem that what do? We have a function, because like function by default overrides templates. Yeah, if you specify a function and a template, we ignore template. But this way we don't have listable true false. I like it. So either template or listable template, basically.
Right.
If you specify both, what do? We ignore one or we do both?
We give an error message.
We give an error message. Perfect.
Well, I don't know. I mean, if we can do both, does it make sense to do both?
I'm thinking probably not, because then you get confused outputs.
Right.
The thing is, it's a bit cumbersome to write, but I mean, still better than having both.
Yeah, I mean, it's cumbersome to write, but not longer than writing template and then
Definitely not.
listable true. Yeah, so
yeah, I like it.
We're long past with at least 25 years past the typing length problem. You know, it'll autocomplete. Don't worry about it.
Oh yes, that's true.
Okay. All right.
Okay, does I like it? This was sorted out. Now, condition is more problematic. And you will not like what we have here, but we need a better way to package it, basically.
Okay,
so
what is it doing?
Okay, let's look at the example, and then we can comment on the syntax.
I don't understand this. The condition is applied when?
Before running the node. It's a gatekeeper. So technically, it lets you save some computation and time by choosing which path to blocking some paths in the graph evaluation.
Okay, so this node then will do nothing. This node will be inert unless the condition is valid.
Exactly. You enter the node if the condition is true. And currently, to keep the symmetry between templates and condition, and also because we are looking for template slot to determine to find out dependency, it's a templates expression, which isn't super convincing.
What would it normally be applied to?
Just
the
like
association.
Templates. Yeah, the association of results from dependency node from the node.
Well, no, wait a minute. Something's coming into the review node.
Mm-hmm.
Okay, what's coming in as an association, correct?
Right, exactly.
Okay, this condition is a function on that association, correct?
Correct.
So why the hell isn't it called, condition function or something?
Well,
because that's technically a template. I mean, if you take it out,
but it isn't a template. It's going to be. It takes.
It's the same as template. To evaluate template, you wrap it in a string template that becomes a template object, and then your template apply it to the association. To evaluate condition, you make a template object out of that, and your template apply to the association. This is how you see. String contains few templates log decide errors. This is
hash decide.
Because it's a template. It's not. This is something that we are like a bit unsure about. So this is completely, as Timothée said, this is completely symmetric with template.
So we could also have exactly what we have for the node. We could also have an association there saying function goes to and a test function input goes to, because we need to figure out the dependency. And that's the same issue that we just met before. So
So
we can
I don't
have,
understand. So test function. Okay, in the template, you're going into the template to see the template slot variables. True or not true?
true.
Okay. So whereas here, well, I mean, you could always say, okay, there's several points that come to me. Okay, one point is the fact that the node that makes the conditional choice is the same node as the node that would run if the conditional choice is true. Not obviously correct, but let's pin that on one side for a second. Okay. What occurs to me is that if you want to make explicit, we could have a thing that will try to inspect the expressions to figure out dependencies, but there might be situations in which that's hard to do. And if that's hard to do, you can provide an explicit inputs that tells you what the inputs are so that we can do dependency tracking. And then if we have, let's say we have test inputs, just like we have inputs, test inputs. Test inputs is what we need if you're giving a function.
Exactly.
If you're giving a template, we can auto-magically find the inputs, although you could give them as a courtesy if you wanted to. And in test function, it will, you give test inputs as well. And then test function looks just like function, given that, and then it has test inputs. And maybe we can be cleverer in the future, or in the case where if you can give we could have test function and test template, I suppose, if that makes sense.
Instead of condition, yes.
So test function, test template, and test inputs, and it's exactly symmetrical with function, template, and inputs.
Yes.
And with function, you need to use inputs. With template, you generally don't need to use inputs because it's automatically done. With function, maybe in the future, worst case is you try it without specifying it. And if it can't auto-magically discover the dependencies, it will give a message. But if it can, then be happy.
Makes sense.
It's also more likely that we find some dependency, but we are not exhaustive. But yes, I mean, it's if the user has a way to force it, we're all good.
Yes, I think so. So okay, so this is the test. At every node, there's a test, and if the test fails, and can you have multiple tests, or is it just one test?
One test for now.
Okay.
I don't.
For each
I
node.
mean, you can use and, yeah, or.
Yes.
So
Yeah, okay,
that's
fine.
super easy
Fine.
to combine.
Okay. All right. Fine. All right. I think we have a design there.
No, wait. No, I want to poke you. You had this point like that you were not sure if the test, the node making the test and the node making the result should be on the same.
But I
should be
convinced
done
myself
together.
that's not right. I think it's more convenient to just be able to say, just don't run this node, rather than
Okay.
some crazy thing where you've had, a feeder for a node in the graph.
Okay. I mean, I do agree, but I wanted
Yeah,
to
right.
check.
No, I mean, I was
if there
just
was
considering
ideas.
that question, whether it would make it simpler, because then you could have, then a test node could have function template inputs just the same as a regular node, but it doesn't make sense. It's better to have that be.
I mean, one thing I like about this design that we updated several times, and Timothy had a very good idea, I think, is that there are no ports, no special test nodes. Yeah, everything is a normal node. Even the inputs are normal nodes. And the nice thing that you can do with this is that if you use the association to give the input to the function, you can give input to the final node. No, the fact that some nodes are inputs is only because they are like unresolved dependencies, basically.
Yeah. Yep.
And this is very nice for like human in the loop, because you can at any point force the node to have a specific result.
Yep. Yeah, that is nice. Okay, this looks good to me. Very nice. So, and I like the idea of using this as a model for graph evaluation. So let's just take a look up here. Okay. Okay. Well, we're changing this a bit.
Yes,
Yes.
exactly.
I'm changing this a bit. By the way, you can presumably also have listable function as well as listable template. Although it's less useful because you can, I don't know whether it's less useful because otherwise you're running a map inside the function. So I think listable function.
I think it's strictly, I talked to Timothy about this. It's strictly more useful not to have it because you are basically doing session submit several times. It's strictly better to do it only once.
Why?
Like,
I mean, if the thing is mapping over several items, don't you want each item to be independently asynchronous?
If performance-wise, you're degrading the evaluation time, and that might
Why?
Because of the overheads of the task handling framework. And
I don't understand that. I mean, if you've got a list of 10 items and you've got some function f, and you're going to asynchronously run it. So the alternative is inside the function, you are saying map f over your list of 10 things.
Exactly. But it's not really async. I mean, it's asynchronous in the same way, yeah, because the kernel is single-threaded. So if I submit 10 evaluations, they are still going to happen sequentially.
No, but
unless I use local submit.
Yeah, but I understand. But the evaluations here will typically be LLM evaluations.
Well, no, F is. I mean, if you want an LLM evaluation, you are much better off with the templates. We add the function here because with this you bridge it with all the rest of the code.
I get it.
Yeah,
so the function is primarily for the function is primarily just ordinary code.
Free form.
Exactly, like that string split that we had, or like whatever. Yeah.
So you had full expressivity.
Wait a minute. I'm wondering whether we should distinguish that a bit more. So the template is something that will be fed to LLM, LLM function, right?
Exactly.
But the function is just a piece of code to run, right? It's just an evaluation to be done at that.
Correct.
Now. Are you sure we shouldn't call template LLM template?
Prompt template?
Well, I mean, this is called LLMGraph. So I was thinking that we could collect the LLM thing outside.
Okay, but the problem is that the function is not an LLM function, right? The function thing is just code.
You think it might be confusing?
I think it might be confusing. I mean, evaluation function is not right because that suggests it's the whole evaluation.
Mm-hmm.
I mean, maybe node function is better.
Okay, node function, node test function.
I think test function is sort of okay on its own.
Because it has a qualifier on function.
Yeah, because it's not. Because the point is that node function. See, template is all.
Template is probably not going to be very used in fully named because the whole idea is to have so many shortcuts that this is a VIP from the function. If you put a string, it's a string template. If you put a template object, it gets resolved.
Yeah, so, but now you have template versus listable template, or you have
test function,
the test function. So like that would force you to use template. I don't hate node function, test function. As you said, we have auto completion.
Yeah, I think that's what we should go with. Because I think if we call it function, it's too symmetric with template, and it will be confusing.
Okay, makes sense.
I think. I mean, it would be nice if it was more like an evaluation function, but I think that will be confusing as well.
Yeah, because evaluation, I mean, it doesn't really qualify what evaluation we are talking about. Yeah.
Um, and if we have both a function, node function, and a template, what wins?
Node function. If you specify both, right now, the function wins.
Okay, I think we should give a message in that case.
We could also fail if you specify both.
Yeah. I wish there was something that said that a template is something that is being used to feed to an LLM, and the node function is just code.
We could potentially name it prompt, so that we instead of saying what it is, we say what we do with it. And
the only remember we had prompt and then we remove it because I mean that can also be an LLM function.
what
can be the template?
Yeah.
No, well,
no.
I mean, in the case I mean, the LLM function is a template and is a template plus the LLM evaluation. We could, we could probably accept it as under a specific key if we want. But the point is, people will not yeah, okay. If we want to stick everything under one key, template is better. But we could have aliases, we are internally, when we have an LLM function, we are taking it apart in order to extract the prompt, to extract the LLM evaluator, and to run them to LLM synthesize. So we could also have LLM function as a key and template being prompt for the sake of and accept any inputs. It's just
hold on. I mean, basically what you're saying is template could be an LLM function, which is pretty confusing, given that we also have a node function.
Basically we can provide two types of function, either an LLM function or a node function. If we provide an LLM function, the way we can specify it is from the very minimal, we provide a prompt, and the LLM function is the LLM function of the prompt and everything else to automatic, or we provide a template object which is the same, or we provide a fully fledged LLM function, which means the prompt and an LLM evaluator specification. So
I mean, I'm kind of thinking that we could call this, forget template, we could call it LLM function, and it can be
it could be a template or a prompt
or a string,
or a string, and it's just that it represents the LLM function that you would construct with LLM function wrapped around, and it's just a courtesy that it's shortcut.
Yeah, let me think. I'm thinking LLM function, node function, test function. Maybe. It's all a bit complicated, but that seems like it's a, the explanation there is at each node, the LLM function is run against an LLM. The node function is run against the evaluator. The test function is run against the evaluator. Right, so LLM function has an LLM evaluator. Node function and test function just have regular evaluators. Correct?
Yes.
So then it becomes listable LLM function, which is not the worst thing in the world. That's what I would suggest. See how it feels. Let's look at this asynchronous versus synchronous thing here. What is this? LLMGraph submit. I mean, that's a traditional submit function.
Yes.
Okay, an LLMGraph with a property extracts that property of the output, which you could also get. We don't have a way. That's the only way to get that property from running the LLM graph. Information of LLM graph gives the static information about the LLM graph. Correct?
Exactly.
Yes.
I mean, if you want use information, you do LLM graph input comma LLM graph property, and then you can analyze that.
Say that again.
So you can do. Let's say that you want all the nodes, yeah. So you do LLM graph input comma all instead of automatic, and you get an association with all the outputs. Or you can do LLM graph input comma string LLM graph.
Okay.
And that's returning the annotated LLM graph.
And then the instantiated LLM graph.
Exactly.
Right. Okay, looking good. I have to go, but we have another design review coming right up here. So yeah, anything else we need to cover here? Looks nice.
There was semantic re-rank that we didn't manage to cover with in the machine learning review.
Well, where is
yesterday.
that? Is that here?
No, but I have it easy on the other notebook, but we don't have time now.
I think we have to reschedule something for that.
Okay, it's not going to be long. It's going to be like half an hour. It's probably going to be enough.
Okay, I mean
more
semantic
dense.
re-rank.
It's the packaging of a re-ranking. Should be insidious.
Well, I don't know.
No, sorry, it's called semantic ranking. Semantic ranking. It's because we decided to call it re-rank only in semantic search because it's re-ranking. Yeah, it's only ranking.
So it's a sort function of some kind.
Exactly. It's
Why
quite simple in the end.
semantic sort.
Could be called semantic sort as well.
Well, maybe ranking is better. We have some ranking functions also. Okay, this will not take long, but we cannot do it right now. So for another time, but this LLM graph is looking nice. Well done. That was good. Okay.
Thank you.
See you guys soon.